All right, so everybody can see my screen.
Mhm.
All right, so crazy day today, but we still have to manage to get together and talk and go through different things that we are all working on, so that we can kind of push the company forward and the standards forward, and it's really necessary to do this. So one project that we just wrapped up recently is 66.3. Street. We're adding a dormer, and it was a good opportunity for me to go through. Sorry, some stuff is installing, but to go through a process with Julio of using the structural calculations, the StructCalc software to track the loads throughout a project all the way down to the foundation, and we haven't been necessarily doing it that way as much, mostly because we haven't needed to. We haven't had a necessity to do that. So a few things I'm gonna talk about the project so that you understand what we're doing is probably the best way is just going through the plans. So the project, um, my computer is slow, but so the project is a very bizarre structure, old structure in Metfor that the owner has been adding pieces to taking pieces from is in many ways very confusing in the way that we've been doing it because of his own way of thinking, right? So first, we're gonna be adding a dormer to one side of the roof. Then, he wanted to extend. It was just a little dormer. Then he kept changing. Then he wanted to change this other dormer. Then he wants to. It become very very crazy. But long story short, this sharp roof right here, which I probably would guess was also like that here, and this is an addition over time. Now he wants to level up, get rid of this little dormer that we see right here on this other side. And basically, the things that we need to think about when we're doing this is, we're gonna need to do new roof rafters. We might need to do a new roof beam, ridge beam. These pieces of floors that we have here now are gonna have to extend, so we're gonna need to probably add another beam to join them, and new floor joists and new floor joists. And then how does that get transferred all the way down to the foundation? So I'll try to make this as quick and efficient as possible. But that's the task at hand. We went through, there are little demo plans. We're basically removing this whole roof right here, portion of this roof right here, um, right, to be able to do that. Then we went through our what we're proposing. Things that this wasn't on the plans, and it wasn't on the plans. We picked it up as we went, but it was critical that we picked it up. And it's the fact that since we're extending uh, that roof now, the floors below are going to gain space. So this right here is going to gain this much space. So we need to size a beam right here that will touch, hold these joists that are in here, the existing joists, and then the new joists, which is what we really care about the most. And then we're going to need another beam in here that will be below and is going to be holding up the entire wall. Below, we also have another little bit of the roof that will gain another space. It's better explained on on section, but then below the way at the ground level, we're gonna need to put some posts that will be supporting this beam right here and the beam right here that will support the wall. Not trying to make it so confusing, but here you will get it all. So this is a new roof. This is a new wall. This roof right here is gonna gain this floor right here is going to gain more space. This floor right here is going to gain a little bit more space. And if you see the contrast between existing and new, you see what I'm talking about. Basically, all of this right here, not all of it, but we started here. We're going to take out whatever floor joists were here before that we're probably attaching to the floor, to the roof, and we're going to just extend it all the way through. And then here, this piece is probably existing. It's going to be still be existing, but we're still sizing it anyway because it was very awkward before. So let's just put new floor joists there and do that whole piece. What's the learning here? Well, the project started with the idea was that we were just adding a dormer, right? Extending a roof. And in turn, we were just gonna be sizing, these roof rafters, connecting the existing roof rafters in here into this existing ridge beam, and probably sizing a new ridge beam, and this all was gonna supposedly land on this wall, which is an exterior wall and has a foundation. That's not the case. It's not landing on that wall. It's floating. So because it's floating, we picked up that we need a beam here that need to support it. And how do we size that beam? Right? Is it just gonna be supporting this floor? No, it's supporting this floor, portion of this floor, portion of this roof, this entire wall. All of it's gonna line in there. And basically also this roof right here is being supported partially by it. So how do we do that? Well, it's not straightforward. So I would like to say it's pretty straightforward. It's not. It's really not at all. So what do we do? Well, I'll open up structural calculation software. And I want you guys all to always think about your own processes when you're doing this. How do we do a calculation? First, we should probably start all the way at the roof. Know what the loads are all the way at the roof and move all of our weight down little by little. So,
Darwin, by the way, are you recording?
I am
Oh,
recording. Yeah,
great, great.
it should be. So we're gonna start all the way up, and then what do we need to know? So this plan right here this is actually the plans that we had before, but it wasn't enough. We needed to do framing plans for the other pieces, so we had to add other ones. So what's the first thing we need to know? Well, this is where we have our existing ridge beam, and we're gonna leave that existing ridge beam as it is. And that ridge beam, by the way, there's walls in here, exterior walls. So they're supporting this roof. We don't have to worry about that. We only have to worry about half of this one for this ridge beam right here, and half of this guy for this ridge beam right here. And then the rest is gonna go all the way down. So what do we do first? Now, our beam below is only here, this side, right? Like this area right here. We're only worrying about this piece right here. The rest of this still has a wall and it's gonna transfer all the way down. This is the critical area because this roof is existing right here right now. We're just gonna put new rafters and keep roof rafters and keep the same, like it changed the same slope. But all of this is already known where to be supported. It already has an exterior wall, so I don't worry about it. So what do we worry about? This guy. So first things first, the owner wanted to see how could we add a collar tie to this system so that we're gonna use this existing ridge beam, but also reinforce it with collar ties. And he wanted to know what this roof rafter needed to be. So first thing I ever use a collar tie on this software. So we're gonna go to collar tie. We're gonna find collar tie in here, and it is that guy right here. Now, the collar ties wanna know what they're gonna ask you for some questions like what's the collar tie, you know, what's the slope of the roof that we're using, how much is the overhang, how much is the roof pitch, but at the same time this is sizing your floor your roof rafters, so you don't have to size roof rafters separately. So for this project, what do we need to know? So what's the pitch of this roof? I'm gonna go in section very quickly, and he told me I think it was 6 and 12. So what's the pitch of this? So I basically just draw this triangle. That's just my way of doing this thing. And then I give it, it's always 12 and something, right? So I'm gonna make this 1 foot. And then I'm gonna know what it is. Pitch of this thing is 2 and 12, okay? That's what it is right now, 2 and 12. 2.5, you could call it 2.5 and 12. So that's the pitch of this roof. It's different from what he told me, actually, to be honest. Now that I'm looking at it, it's concerning. But let's just go here and say, okay, what's the roof pitch? 2 and 12. Great. What else do we need to know? Oh, sorry, it's opening another rabbit. Let me just close that out. What else do we need to know? So what else is it asking for? So it's asking for what the roof rafter span is going to have to be. So let me just close this guy out. Now, when you want to open Revit, it doesn't open right away. When you don't need it to open, it really opens right away, right? It's like super crazy. Let's close that out. All right, so what's the span? The span is the distance from this center line right here to here. That's how much these roof rafters are going to span. So you do that and say it's going to be 19.5. What I do is I call it, and that's this distance. You can see it right here from here to here. It wants to know what that is. So that's going to be what it was 19.5. I would say 19.5, which is actually more. So, and sometimes we just do 20, right? And just over design a little. That's okay. So now we know what that is. We know what the roof pitch is. Great. So now these rafters, this roof rafters is what we're sizing. And we're going to use solid sawn. And we're going to go to our Douglas fir number 2. And, you know, I always go through the process of checking sizes. Well, that doesn't pass. Of course not. It's 2x4s. That's not going to pass. So we know that we're going to be using some sort of 2x12. Great. One 2x12 at 24 inches in center will not do it. Let's go back to 16. Does not do it. Guess what? We know it won't do it. I already knew that. It's gonna have to be 2 of them. Actually, 2 of them at 16 inches in center don't pass either. By the way, there's not a foot eve. It's probably like 8 inches eve, so that's not like that much of an overhang. So this is not passing right now. None of these guys are passing right now. So what do? You can either change the grade to select structural. That might help it. It's inadequate by 5.4. What do? We can change this to 12 inches in center, and ta-da, 12 inches in center will pass. Now, this is different from what we size on the drawing, to be honest. I'm doing this quickly on the spot, but 2 and 12 pitch with 2 2x12s together at 12 inches in center will pass using the collar tie. It does not necessarily need a ridge beam, okay? Like a beam will not be doing anything. So we're gonna be using the same beam that we already had here, and we're gonna save this. So that's your collar tie already has been sized. You're good in here, all perfect. He wanted it to be like 3.5 in here for the distance because he wants to use this space for dock work. Maybe that's one of the reasons why I didn't have to do, because the lower you put the collar tie, the stronger it's gonna be. So that's why I don't have to go to 12 inches in center. That was the variable that I was missing. So the lower you put this, you can see how stronger it's gonna make it, right? You can tell. So that's basically sizing the roof rafters that are gonna go this side and this side. So we're good. All right, it's pretty much on center. The ridge beams is pretty much on center. So that already has the load that we need to have. What else do we need to size now? So we already sized. By the way, this right here is that collar tie. And we used, instead of using the 2x4 that I asked, we used 2x6. Does not really do much. It's still 55.9 adequate. So that doesn't do much. He just wanted it to be that more stronger. All right. So what else? So we already have this piece. It's gonna be supported by something. What is it being supported by? Supported by a wall. All right. So what do? I will go here and design a wall. Boom. So that wall, for the sake of time, I made that wall go all the way from here to here. So we need to know the height of that wall. That wall is 16, well, let's call it 17 feet tall. So what's the wall height? 17 feet tall. I'm going here at the top, 17 feet tall. And we're gonna make it by 2x6, 16 inches on center. Great, right? There's a problem here. It's not loading anything onto it. It's wrong. We gotta go to load tracker right here and say, you're gonna be supporting something. Well, one thing, when you get this problem is because you haven't saved this project, okay? You have to be saving as you go. So yes, I'm gonna save these, and I'm gonna tell you a method of how we save. I'm gonna save it on my desktop for now, but it's always a project number. I'm gonna just write project number, you know, project name, and you know, it's gonna be like structural report and the date. 5/19/2021. I'm not doing what I'm saying. I'm telling you what to do. That's all. Okay. So then we go here. Now it's saved. We saved the collar ties. We saved this piece, right? But this wall is not doing anything right now. It's just supporting itself. We got to go there and say, you're going to be supporting that collar tie, which will be supporting all of these loads that's already been calculated onto it, okay? And you know, you pick 8.8, doesn't really matter. It's just supporting that, boom, okay? And you don't say yes to continue loading because it's not gonna be supporting much more unless you want it to be supporting much more, okay? So to be quite honest, maybe we want it to be supporting more, to be honest. But for the purpose of this, I'm gonna say no. So now we got the collar tie that supports the roof. The roof is being supported by that wall. What else do we have? Well, we also have to come and size this floor joist right here and this floor joist right here, right? And what is that floor joist going to be? That floor joist is going to be, I always draw some lines. So the floor joist itself is going to be about 12'3" in length. So we're going to do floor joist. And the span is going to be 12. You know what? Let's call it 12.5. 12.5. That's the span, right? And it's just supporting, you know, its floor. It's going to be 2x10s. That's what we're going to be doing. It's okay. There's no much more load on it right now, okay? So we have that floor joist right here. That's going to span that 12. I put 12.6. That already has its own, it already knows the loads, distributed load, floor life load, floor dead load. That's all good, no problem, okay? Then one thing I do, the next thing that we're gonna do is also size this other joist. This other joist, it's gonna be from here to there, and it's gonna be 5 feet. We're gonna use the same thing for joist. Sorry, 5 feet. Sorry. And we're gonna save it. So we already have joist 3. We already have joist 4. Right? So we already have sized this joist and this joist, and we've already sized that wall. So now we can potentially size this baby right here. Why? Because we already have loaded that guy with this guy. And basically, one thing I wanted to tell you, remember when I said that you could have added more loads to this wall? You could have added that joist and this joist to that wall. So that way you can track it. But I really want to show you how you can manually go ahead and track all of it. So we're going to be sizing our baby beam, this beam. What do we need to know? Well, on this one, I will go to multi-load and multi-span. It's just my preference, and you'll see why. But I save everything. I go back and save everything so that they are registered on the project. Save everything. And I'm going to save everything again. Right? And I open the last one so that it continues making this in order. So then we're going to go to multi-load and multi-span. Boom. What are the things that we need to know to size this beam? What we need to know is how long it's going to go. That's the first thing we need to know. So that beam, and the best place to find that out will be on the plans that we showed before. Actually, and that's in folder, right here. That beam is going to be this length right here. It's going to go from like here to here. All right, it's going to be like 13 feet. Where do you see it better? It's this area right here that we spoke about before, right? So it's going to be a 13 feet long beam, 13 feet. Okay, that's the span length. And what is it supporting? So it's going to be supporting. So you can go to point loads right here and say, well, actually, you can, if you do point loads, you'll see you have no options. There's no column sitting on it. Point loads are columns. There's no column sitting on it. So you're not going to use point loads. You're going to go to uniform live load right here. And when you go to uniform live load, why are you supporting on this? Well, you're supporting, do you do the collar ties? No, I wouldn't do the collar ties. I'll tell you why. Because you're going to put the wall that already is supporting the collar ties. And the load of the wall is already being added on. So you're gonna support the wall, and it's gonna support the floor joist. So you're gonna keep saying yes, and it's gonna support the other floor joist 4. Okay, and then you're gonna say no more and done. So you see supporting the wall, which is supporting the roof, which is support, and then the joist, you could have set up the wall to support the joist also, like I said before, but you don't have to, right? Because you just set it separately. So you're supporting the wall, we're supporting the roof, supporting the joist, and supporting the joist. So that's a big load right there. And you will see the difference. Like if I was to take out that one, these diagrams, by the way, they get smaller. I'm gonna still add it, but they get smaller because the load on it is less. So joist 3, I'm gonna do just again. Okay, nope, done. And you'd run the calculation. So we know 2x4 is not gonna do it. We're gonna definitely go to structural composites. We're gonna go to, I don't know. You can go to that, like test it. You can test it. It fails, right? If you put 3, it fails. We actually ended up doing like a 16-inch, to be honest, and we ended up doing like 3 of them, and that's what we did. And it passes by 45%. Okay. And now what you're like, oh, I'm done. Well, no, you're not done. I want you guys to always go through this process of understanding what you're doing. Loads got to go all the way down to the ground. So this beam is floating right now. By the way, we sized other beams in here and another beam in here, but I'm not going to get to those. Those are simple beams we already know how to calculate because they're going to be supporting half of this load and half of this load and half of this load and half of this load. Doesn't matter. And they happen to be landing on walls. So they're not so much of a big deal. You're not done because right now this thing is floating. This thing is floating. Right? Your beam is somewhere in here in this section. It's not modeled, doesn't need to be modeled, but it's floating right now. So where is it? We need to size columns now, right? So what do? We go to our structural calculation software and we go and say column, find column. By the way, I save it. Good. Column. By the way, I like that I'm doing this very quickly. It's driving the same way. The loads are still pretty similar to what I had before. So it means we did it before very well. So column, right? And what do? Well, we're gonna size a column, but what do? We do actual live load, and it's gonna be supporting that beam that we spoke about on either point A or point B. So we say point A. Boom. We don't keep loading it because there's nothing else on it. And you already loaded that load onto that column, and then what that's the correct load. That 1 3/4 by 5.5, it's not gonna do it. One thing that we've been doing, I mean, Julio has gotten very good. Most of us have gotten really good at knowing these things. So we typically gonna go to we could probably go to the LVL like we have, but we're gonna go to the solid zone. That's always the typical thing. And we have a good idea that a 5x5 is gonna do it. 5 by 5. And you guys know 5 by 5 is 5.5 by 5.5. It's gonna do it. And he does it. And he always does. I mean, could we do a 4 by 4? Probably we could do a 4 by 4. No, it doesn't. So 5 by 5 is all good. Now to drive all this thing all the way home, right? We've already basically completed our process on this model. Why? Because there's gonna be a column inside this wall and inside this other wall on this other side that we don't see, that will support that beam, that will support this joist, that will support this portion of this roof that we're talking about. Okay. But we're not done, right? Like, where's it sitting? It needs to be sitting on a foundation, right? So we assume there is a foundation on this project, and there should be a foundation on this wall, because what is this tower being supported by? It needs to have a foundation. And what is this other one? But if there isn't a foundation, right, to complete this job, we got to size a footing or a foundation wall. So I'm going to do both of them to show you how it's done. So real quickly, we save this guy. We're gonna say, okay, foundation, which is all the way here. And by the way, you do footing, I mean, you do foundation, or you do foundation wall. You can do different things, right? So depending on what you like. If it's a continuous, it's just a foundation wall. If it's a square, it's just gonna be like a pad, like a concrete pad. It could be a rectangular, it could be a round, like the sonotubes, it could be whichever. So I'm gonna size a square one real quickly. And then you're like, well, do you just put it in there and you're done? You're not done. You gotta go to live load track, and you're gonna track what? The column or the beam? You gotta track the column. The column's gonna come down, and you're gonna do it. You're gonna say no. And that column is driving all of the loads all the way down, you know? So what sizes are we gonna do? So here you don't play with much of this anymore. You're gonna play with how big and how deep this thing can be. So right now it says, what's the column width? Well, the column width is not 5, it's not 4, it's actually 5. In fact, it's actually 6 inches, right? So it's telling you what column am I holding? You're holding a 6-inch column. And I always just make these 6 inches and 6 inches in here if it's supporting a 5x5 post. And then what's the footing depth? Well, what does it need to be? 12 inches don't do 10 inches don't do it. Let's make it 12 inches. So a 12-inch by 3 by 3 feet does it, right? And one thing I want you to do is sometimes after you calculate it, go back to the model and model these guys the way they are supposed to be. That way they show up the way they're supposed to show. You don't have to model them, but at least size it with the drawing. And then you're done. You're like, well, now when you size in 2 columns, you're gonna call column 16 twice on the model. Okay, and that's the report for this whole project right here. So what do we do again? These were the floors that were missing on this project. Now we size all the columns because of the other beam, but this column right here is this 5x5, right? And this column right here is this 5x5. And we always tell to refer to the column 12 on the report, right? We already sized these guys. We're already sized. All of these elements are sized and they're appropriate. Now you would say, well, we never told the beam how big this wall was gonna be. Well, the wall is as big as the beam. We told the beam how big the beam was going to need to be. The beam knows how much of all of this because the beam all the way back asked for what's the span of the beam, the multi-loaded beam. So it's supporting 13 feet of something. Well, supporting 13 feet of wall and 13 feet of roof with collar tie. Okay. And with that being said, we've closed on this one. I'm going to stop the recording for a minute and then we can ask any questions, okay?